Leonhard Euler was born in Basel, Switzerland in April of 1707. He was said to be a pioneering mathematician and physicist, as he made important discoveries in the fields of infinitesimal calculus and graph theory. Euler is considered to be the predominant mathematician of the 18th century and did most of his work in St. Petersburg, Russia, and Berlin, Prussia. Euler made significant progress in the field of differential equations, which is a mathematical equation that relates some function of one or more variables with its derivatives. In order to solve a differential equation via Euler's method, we must have both a dy dx and an initial condition. For this problem, we were given both criteria, our equation being y squared times the quantity of 2x plus 2, and initial condition of 0, negative 1. Then a table can be constructed consisting of 5 columns labeled x, y, dy dx, delta x, and delta y. Now we can go ahead and plug in our first point under the x and y column. The question asks us to approximate y when x is 1/2 with 2 equal steps. This information allows us to calculate our x values and delta x value. In order to get from 0 to 1/2 in 2 steps, the change in x must be 1/4 each time. Now plug in the initial condition into the equation in order to earn a dy dx value for the table, which is a value of 2. Next, multiply the dy dx and delta x value in order to get delta y. As the delta x's will cancel, a value of 1/2 is reached. Add this delta y value to the next y row and repeat the process until the y row is filled when x is 1/2. The final answer will be written as f of 1/2 is approximately negative 0.34375 or negative 11/32. Guillaume de l'Hôpital was born in Paris, France in the year 1661. He came from a military family but abandoned the family career due to poor eyesight and pursued his interest in mathematics. He completed his studies at the French Academy of Sciences and is known for his work in infinitesimal calculus and differential geometry of curves. L'Hôpital is firmly associated with L'Hôpital's rule for calculating limits involving indeterminate forms of 0 over 0 and infinity over infinity. To utilize L'Hôpital's rule, the limit must equal either 0 over 0 or infinity over infinity when plugging in the value that x is approaching. In the limit provided, x squared minus 16 over x minus 4, when plugging in a value of 4, the limit comes out to 0 over 0. When this occurs, we can derive the limit until 0 will no longer appear in the denominator. In this case, the derived limit will become 2x over 1. We can now plug in the value of 4 into the limit to earn a value of 8. Thus, it can be said that the limit of f of x as x approaches 4 is 8. George Riemann was born in Breslin's Kingdom of Hanover, or modern-day Germany, in September of 1826. Though he was vastly gifted in his calculation abilities from an early age, Riemann suffered from shyness and a fear of speaking in public. He overcame this fear when he attended George August University of Göttingen and Berlin University to pursue his math abilities. Riemann made major contributions to real analysis and defined the Riemann integral by means of Riemann sums. Riemann sums are used to approximate the area between a curve and an x-axis. In the example provided, the curve is given as y equals x squared plus 1 with the interval 0 to 2. We are told to approximate the area in this interval using 4 rectangles. Additionally, we will use a left Riemann sum to approximate the area. In order to split the domain into 4 equal sections, each length of a rectangle will be 1/2. Then we will plug in that x value into the equation to earn our height. As this is a left Riemann sum, we will start with the x that equals 0 and will then calculate 1 as the height after plugging into the equation of the curve. Do this for the remaining rectangles and add the values together to conclude with the approximated area. Furthermore, the value that is calculated will be an under-approximation as the function is strictly increasing. What?